Okay, ladies and gentlemen, so for this lesson, we're going to be solving quadratic equations by reasoning. So how many solutions does each equation have? What are the solutions? And be prepared to explain what you know. So one might reason that here x is equal to 3 because I can check 3 squared is equal to 9. So 3 is a solution. However, that would only give you half of the solutions because I also know that if I take -3 and square it, it's also equal to 9. So there are two solutions here. X is equal to 3 and x is equal to -3. Now, we learned in first semester how to study these with more formal ways to solve these equations. So I'm going to rewrite for number 1, x squared equals 9. And just a reminder, if I want to undo squaring, we would take the square root. So again, the square root undoes x squared. And then when I take a square root, though, we get a positive value and a negative value. So we would get x equals 3 and x equals -3. Similarly here for number 2, if I'm working to solve that, if I have x squared equals 0, we could take the square root of both sides and get x equals positive 0 and also x equals -0. But the opposite of 0 is 0. So really, we only have one solution, x equals 0. Now, the equations are going to get a little bit more complicated. If we have x squared minus 1 equals 3, we're going to isolate x squared. So we're going to add 1 to both sides. -1 plus 1 will make 0. So we have x squared equals 3 plus 1 is 4. Taking the square root of both sides, we would get x is equal to the square root of 4 is 2. But then we also have the negative value, and x would also equal -2. And we're going to solve a little bit more of a complicated equation for number 4. So let me label number 3 first. All right, number 4. So I'm going to rewrite the equation. 2x squared equals 50. Now, in formally solving this, I want to isolate the variable x squared. So I do that by dividing both sides by 2. And I get x squared is equal to 2 divided by 2 makes 1x squared. Or x squared is just x squared, and 50 divided by 2 is 25. So now we've isolated x squared, and we want to undo that by square rooting both sides. And we would get x is equal to undo that, we would take the square root of 25. So I want to show you how to do that on your calculator. I can see that square root button in blue. So if I press second, x squared, and then type in 25, we could get 5. Or -5. Then we're going to solve number 5 formally. Number 5, we have x plus 1 times x plus 1 equals 0. And we learned that this is in factored form. So if I have two products in factored form and they multiply to be 0, one of them has to be 0. So we know that x plus 1 equals 0. And we can also set the other factor, x plus 1 equals 0. Now, they're both the same equation, so I only need to solve one of them. So I subtract 1 on both sides, and I get x is equal to -1. Number 6, same idea. I see a product in factored form. We have x and then times x minus 6 equals 0. Set them both equal to 0. Add 6 to both sides. So x equals 0 and x equals 6. Number 7, we might reason a solution. I know that 2 times 2 is equal to 4. So if I knew that, I could have x minus 1 is equal to 2. And I can add 1 to both sides. So we could get x equals 3 would be one solution. And then check 3 minus 1 is 2 times 2 is 4. So that is a solution. I could also have negative 1 because if I did x minus 1 is equal to negative 2, I'm sorry, negative 2 times negative 2 is also positive 4. So if I set x minus 1 equal to negative 2, we could solve and get x equals negative 1. So now we're going to look at more formal solutions and more complicated equations. So in order to solve more complex solutions, I'm solving n squared plus 4 equals 404. I want to figure out, well, what value for n could I square it and then add 4 and get 404? And we know there's going to be a positive and a negative value. We just have to figure out formally what they are. So first, I'm going to isolate n squared. So to get rid of the plus 4, I subtract 4, and I get n squared equals 400. And then to undo the square, I take the square root. So n is going to equal, and I can do the square root of 400. We see up there it's 20, but just in case you can't need a calculator, it's fine. So n equals 20, and I only actually have half of my solution. I forgot the negative value. So n also equals negative 20. And we can go back and check. So 20 squared plus 4 equals, and I'm going to use a calculator, and that gave me 404. Now, when I check with the other one, if I square negative 20, I have to put it in the parentheses. So negative 20 squared plus 4. That also equals 404. So here, for our second equation, we want to isolate n squared, so 3 times n squared. To get rid of that, multiplying by 3, divide both sides by 3. So if I do 432 divided by 3, I get 144. And then we can take the square root of both sides. And the square root of 144 is 12. And then I got to remember I have a positive value and a negative value. And then the same thing over here. If we have n plus 1 squared, we can take the square root of both sides. So we have n plus 1 equals 12, and n plus 1 equals negative 12. And then subtracting 1 from both sides, n equals 11. Then subtracting 1 from both sides, n equals negative 13. And for our last one, a little bit more complicated. So n minus 5 in parentheses squared minus 30 is 70. I want to isolate the variable in the parentheses, so I'm going to get rid of the minus 30 by adding 30. So I get n minus 5 squared, and that equals 100. Then taking the square root of both sides, we would get n minus 5 equals square root of 100 is 10. However, it could be 10 or negative 10. So I'm actually going to get two equations again. N minus 5 is 10, and n minus 5 equals negative 10. Now, solving these, I would just add 5 to both sides of both equations. So the minus 5 plus 5 is going to make 0. So we bring the n down. 10 plus 5 is 15. add 5 to both sides of the equation, and we would get n equals -5. So our two answers are 15 and -5.